the performance table between the support systems. When I sent this paper to the reviewer, he said to me, he wrote to me and an email to me saying that this is really 3 papers. I do apologize for that, it's a little long, but I'll try to be as brief as possible. So now we want to choose again something that we as mining engineers have to do to choose our criteria. 7 different criteria have been chosen. Displacements, vertical and horizontal, in different ways. Support system cost, of course, economics, very important, and safety factor, of course. This is a typical simple decision tree, that we have a decision tree, we have criteria, and we have alternative, and we have payoffs. Together with those payoffs and the probabilities of each section, each branch of the tree, we calculate EMV, which is expected monetary value. And the alternative which has the higher expected monetary value, of course, is chosen. But in choosing support system, the problem is more complicated than that. And that is because we have more than one criteria. We have 7 different criteria. Support system selection, goal, that is our goal. We have 7 different criteria and 4 different alternatives in here. So we want to choose all these 3 methods one by one to rank for us, so that we have a ranking, so that we have a preference table between C, D, G, and J, which are different support systems. Analytical hierarchy processing, AHP method. This is a structured technique for dealing with complex decisions. We do accept, or we must accept, the selection of a support system for a tunnel is a complex problem because we have different criteria. If we only have as our criteria the matter that we support a tunnel so that it doesn't fall, then that becomes a simple problem. But that is not the only criteria we have. We have others, mainly economics. Rather than prescribing a correct decision, the AHP helps decision maker to find the one that best suits his needs. And it provides a comprehensive and rational framework for strategic decision. The AHP method, just steps are given here. As I said, they're all described quite well in the paper. The hierarchy tree, decision-making matrix, pairwise matrix, and normalization of the matrix, which is a normal step in all these decisions. Relative weights to different criteria, and attribute weights. To select the support system based on AHP, the expert choice software was used. First of all, decision-making tree is constructed. And all the others that we spoke about are done in here. And the result is that J is the most preferred, then G, C, and D. We have also tested the results with overall inconsistency of 0.04, which is quite a lot below 0.1, which is the acceptable threshold. Now, TOPSIS, technique for order preference by similarity to ideal-associated solution. The second method, TOPSIS is another multi-criteria method to identify the solutions from a finite set of alternatives. In here, we do have a finite set of alternatives, which is limited to four different support systems. The concept of TOPSIS is that the chosen alternative should have the shortest distance from the ideal and the furthest distance from the negative ideal solution. So, in other words, being closest to the right one and the furthest away from the wrong one, from the most wrong one. Implementation steps, construction of weighted normalized matrix, which as I said is quite a normal thing to do in these models, determination of the positive ideal and the negative ideal solution, the distance from them, and the relative closeness, and then as a result of all these, the ranking is done between the finite set of alternatives that we have in here, which is 4. Support systems that had a factor of safety of more than 2, C, D, G, and J on top, and the column C1 to C7 are the criteria that we chose. Positive ideal situation, A plus and A minus. The distances, and finally the ranks. Again, J received the rank of 1, the best. Second one, G, C, and D. In this case, they are ranked. In this way, they are ranked. These alternatives are ranked by TOPSIS model. Third one, preference ranking organization method from D. This is yet another multi-criteria decision ranking methodology that determines preference between alternatives. The concept is slightly different. It determines the preference between each 2 alternative systems. Therefore, we'll have to compare all the alternatives two by two. Steps, deviation matrix, preference functions, etc., and then until ranking is produced. Then we have to, again, we consider our 7 criteria, C1 to C7, and we will have each 2 support systems. Each 2, we will have to compare each 2. C against D, C against G, C against J, D against C. They all have to be compared with each other. We have 12 different scenarios and 7 different criteria, and a matrix of deviation for the normalized values that are normalized, and values of the threshold preference. Again, in the column, as you can see, P, C, and D. P of C and D, that is the comparison of C preference between C and D. And we can see some of them have some of the numbers in the table have 0 value. That means that there is no preference between the 2 regarding that criterion only. For example, the vertical displacement. Some 2 systems are quite understandable, quite expected that 2 systems would give the same vertical displacement in one of the points 1, 2, 3, 4 in the top. So there are quite a lot of numbers which are 0. Matrix of preference indexes. Negative flow, then the positive, the outgoing flow, then entering flow, then net flow, which is simply the difference between the 2. And finally, ranking Again, this method also ranked J to be the best, then C, G, and D. Now we go to the summary of the results obtained from the three